Hello everyone and welcome to another video of Vivek Learns. In the last video of PepCoding Level 1 that we had made, we had solved this question of stock span. So what was this question about? So we were given an array representing the prices and we had to find the days or the span, like the span between today and the price before today where the price were higher. So in this video, let's continue the series and let's try to solve the next question, which is largest area histogram. So we are given number n representing size of array. We are given n numbers representing height of bars in a chart. Okay. We are required to find and print the area of largest rectangle in histogram. Okay. So let's try to analyze this problem first and try to understand what it is, what do we have to exactly do. So here we have the question and let's try to draw a diagram for this first. So we'll have the base here and let's try to represent the bars of this bar chart. So we have 6 first, so we'll draw 6 a bit big. 6 here, then we have 2, then we have 5 somewhere here, then we have 4. Okay, then we again have 5, then we have 1, so 1 here, then we have 6 again. So let me draw 6 again from here. Yep, so let me have these elements here, 6, then we'll have 1, oh sorry, this is 2, right? Then we'll have 5, then again we have 4 here, then again 5 here, then this is of height 1, this is again of height 6. So this is how the bars of this bar chart will be represented. Now let's move to the question. So we have to find the area of the largest histogram, area of the largest rectangle, not the histogram, right? So how will we find the area? So we have assumed that the width of this bar is always 1. So what we do is that to find the area of this bar, we'll do 1 times the height, which is 6. Similarly, we can find the area of other bars as well. So area of this bar is 6. For this one it is 2. For this is 5, 4, 5. For this is 1. And for this is also 6. But we'll have some other conditions as well. So if we consider this rectangle which spans from here to here, what will be the area? So area will be 1, 2, 3, the width will be 1, 2, 3, 4, 5. So this is 5. Width is 5 and the height is 2. So 5 times 2 is 10. So that is how we will try to calculate the area. And the solution for this is this one. So we spread the fourth bar to the left and the right. And what we found was that the width is 1, 2, 3, 3. 3 times 4, so it will be 12. So this is the rectangle having the largest area, which is the solution. So how do we find the solution? So before finding the solution, let's have some observations. So we have spread this bar in this bar chart till where? Towards the left and towards the right, correct? So towards the left we have spread it till the smaller element to the left, and towards the right we have spread it till the smaller element to the right. Okay, so in a generalized form, we can have um, something like this. We can have a formula like area is equals to, we'll have to do height times, and then we'll have to write, we can write stock span minus 1, or because this will give us the stock span, right? But we need to have something better. So what we can do is that we can have the indexes of the elements written above them. So let me try to write the indexes. So this is the 0th element, this is the first one, this is the second one, this is the third one, the fourth one, fifth, and then sixth. We expand it. Yeah. So these are the indexes of the elements. So we can say that area of this triangle is the height, and then what we do is that we get the smaller element of the right and the smaller element of the left. Okay, so 5 minus 4 is 1, and then we additionally have to do minus 1. So this is how we'll try to find, right? So we have a generalized formula which gives height times index or index of, let me have it in a bracket, index of smaller element to right minus index of smaller element to the left, and we'll have to also subtract 1 from there. So yeah, so this will be the generalized formula that we will be trying to solve. So for that we'll have to get the smaller index of the right and the smaller index of the left, right? So we can consider those indexes as the left boundary or the right boundary that we have, correct? And we can try to solve that problem. But what if we have this edge case where the smaller index neither is present to the left or nor it is present to the right? So we will discuss that case when we are trying to code it. So first we'll get some array of indexes to the left and array of indexes to the right. Okay. So let me create a new class which is called largest area of histogram. And what can we do here? We erase this, we erase all the logic that we have here, and then we assume that we already have the answer for, let's say, right boundary. Have this is equals to new, and this will be having the same length, and we'll have similar for left boundary. So we'll have to populate these first. So right boundary will be nothing but smaller indexes to the right. So how will we do that? We had done next greater element to the right. Now we'll have to solve for next smaller element. So we create a stack of integers, and will be a right boundary stack is equals to new stack, right? And what we do is we put some elements into that stack, right? So we, for the right boundary dot push, what do we what was the operation? No, not this, right boundary stack dot push. So we push the ARR dot length minus 1 index first, right? And the right boundary, right? So we'll put what do we have to put there? So this element, it doesn't have, okay, this one, it doesn't have any small element to the right. So what we do is we for the smaller element to the right, we can have arr dot length itself. So we can consider a deep valley here to both the sides. So if you fall in this valley, we'll have arr dot length. And if you fall into this valley, we'll have -1. So we'll try to code that right boundary dot right boundary element, right, of arr dot length -1 mm, is equals to, so right boundary of arr dot length -1. Yeah, so for this element it will be arr dot length. Okay, and we'll start iterating now over the array that we have, not the result array, the array that we have. And what do we do? While stack is not empty, is empty. Oh, right, we have this right bound stack, right? And so we'll have this condition for when it is not empty. So we'll have to do some popping operations. So when do we pop? We pop when we'll get a smaller element, right? Yeah. So we'll have first the zeroth element, which is 6. So 6 will be compared to next next element will be compared with 6. So if next element is smaller, we'll pop the element in the stack and we'll push that element into the stack. So if we have 5, 5 is not smaller, so it will push its own index into the stack. So we'll have that logic. If arr of I is greater than, yeah, what do we have here? ARR of stack dot peak, right boundary stack, right boundary stack peak. Then we have to do stack dot pop. I always am writing stack dot pop. Okay, and what will have some conditions after this. So if stack is empty, if right boundary stack dot is empty, so we what do we put? We insert uh, this right boundary. We'll have to populate this array, right? Right boundary of I is equals to arr dot length. Like we had discussed this, right? We'll consider that we'll have some kind of valley, correct? So if you fall, if there is no element smaller than this, then we substitute this number arr dot length there. So I'll have this here, and else what is the error are we getting? So this is the while loop, this is the for loop, right boundary stack. So why have I substituted stack here? When did I replace this? Yeah. So right boundary is of I is equals to arr dot length. Else, what do we have? Right boundary of I will have to substitute something. So we substitute, what value do we substitute? Once we pop, we substitute the stack dot peak, right? Stack dot peak. We'll have this stack, correct? and for either cases we'll have to push into the stack. So we'll have right boundary stack dot push, and we push the index, correct? Yeah, so I think what we can do first is we can try to print this right boundary first. We can have arrays dot toString right boundary stack first. Okay, not this right boundary stack, this right boundary. Okay, so if ARR of I is less is greater, no, is less than, correct? So if it is less, then only we pop. So if we'll have 6 first, then 1 is smaller, yeah, then we'll pop. Yeah. So let's try to run this first. For the inputs, 6, so we'll have 7 elements, 6 2 5 4 5 1 6. We'll have to run it again. Numlock on 7 inputs, 6 2 5 4 5, and then 1 6. So the small element to the right of this is ARR.length. Okay, so we have to start the iteration from the last element, correct? Last element minus 1, my bad. ARR.length minus 1, correct? For that we have already done. So, and it will be greater than equal to 0. So we'll start the iteration from the last part here. 7, then we'll have 6 2 5 4 5 1 and 6. We have got array index out of bounds exception for line number 25. Stack dot peak ARR of I. Oh, we'll do I minus minus, correct? My bad. So sorry for this. 7 and then 6 5. So let me run it again. 6 2, right? 5 4 5 1 and 6. Yeah, so if we see here, there is no element to the small element to the right, so we have substituted a 7 here. Similar is the case for this. For 5 we have small element as 1, correct? So we'll have substituted its index. For 4, uh, for 4 we have substituted 5. For third also we'll have the index 5 substituted, right? And for second we'll also have 5. So second, for third we have small element to the right as 5. So 7 7 is for this, and then 5 1 is for this. Yeah, so for this 5 this will be the smaller one. Yeah, so similarly we will try to find the smaller element to the left, and we'll have a left boundary. So for now we'll start with 1, and for this case we'll start from the 0th element to the first, because we are starting from the left. I plus plus, have I plus plus, and then for this you'll start from we'll have to check if array is empty or not, and this is also similar one, right? Yeah, it's similar. So we'll let me print the, but here we will require a new stack, or but we are not pushing into this stack. So let me name this as left stack. So we push 0 first, and in the we'll have to create a right boundary, right? Left boundary of 0 is -1, and then because there is no smaller element to uh, the 0th element, to the left of the 0th element, so we fall into that valley where we have substituted -1. So we start the iteration from 1, and then we continue, and if array is empty we substitute -1 here, otherwise we substitute stack.peak. Yeah, so I think we can print both the arrays, both the stacks have to be, both the arrays. We can try to run it once. Oh, there are errors in my code. So we'll have right boundary here, right? So we'll have 7 elements: 6, 2, 5, 4, 5, 6. Okay. Yeah, so this is not something we were expecting. So we'll have to put it in left stack, right? Yeah, and we are left boundary stack. Oh, this is the left boundary, correct? We don't have any right thing here in this loop, correct? Let me check that once. Yeah, we don't have, we only have left now. Yeah, so we'll have 7 elements: 6, 2, 5, 4, 5. Then what we'll have? 1 and 6. So every element is -1. So aren't we pushing into the... Oh my bad again. We have left stack here and we aren't pushing into that. 6, 2. Yeah, so towards left of this is -1. For this is also -1. For the second index we'll have 1 as the index. So let me check that. Yeah, we have 1. So for the third and the fourth, for the fourth one we'll have 3. Yeah. 0, 1, 2, 3, 4. For the fourth index we have 3. Yeah. So we have got both the indexes. Now what we can do is that we can loop through the array that we have, and we can have the logic for loop through the array, right, that we have, and we can calculate the max. Let's for have the max area as 0 first. Max area. Let's have it 0 first. So max area is 0, then we'll check in area, int area is equals to the ARR of I times, what do we have? Left boundary, right boundary minus left boundary, right? Right boundary of I minus left boundary of I -1. Okay, and if area is greater than max area, what do? We substitute max area is equals to area. And then at last we print it, the max area, right? So let's try to run it once. We have 7 elements with 6, 2, 5, 4, 5, 1 and 6. Yeah, we are getting the expected output. So let me comment this as well as this. So do we have another test case for this? No, but yeah, so we have solved this largest area of histogram question. So I think we'll stop here for this video. So we'll try to solve this next question that we have. Control Shift O, right, to optimize the imports. Yeah. So in the next video, we'll try to solve the next question of this tags and queue module. So that was all for this video. See you guys in the next one. Thank you.